Hello and welcome back to the class of 5G. We have seen the intent of 1G. Now it is time to look at the actions that were taken to make 1G possible. The first generation of mobile communication was analog. We will take a look into its deeper meaning later, but the most important part is that it was all about making two radios talk to each other. Initially, the talking used to happen in form of information exchange. So on one end, we had the sender or the transmitter, and on the other end, we had receiver. Obviously, to make this conversation possible, we needed a medium which was accessible and comprehensible by both sender and receiver. And such a medium was analog frequencies. Firstly, we had simplex communication, which means the transmitter could only send and the receiver could only receive. Over time, the technology grew, the circuits grew, and the devices were able to encompass both transmitter and receiver. But there was still a bottleneck. One could do one of the two tasks at a time, not simultaneously. Which means that if sender is speaking or if sender is sending, the receiver would not be able to send anything back at that moment. Then, once the sender's turn is over, it was receiver's turn and sender had to stay silent. This was called half-duplex communication. Another one of its bottleneck was it was pretty short-ranged. Walkie-talkies used to work with half-duplex and their highest range was somewhere close to 50 miles. As an upgrade or advancement to all of this, we had full duplex communication, where walkie-talkies were replaced by the first generation analog mobile phones, and their messages went through something called a tower, which consisted of antennas. It means that sender and receiver would not be connected directly. They would be connected to a tower, and the tower would have much higher range. In case the distance between the sender and receiver was too high, which could not be covered by the tower, one tower would talk to another tower, and that way we would have a chain of towers between sender and receiver. You might be wondering, what is frequency? In fact, it is quite amusing that despite the definition and concept of frequency being extremely simple, it is one of the most misunderstood terms in the field of wireless communication. Many times, people just can't seem to visualize it. If you are on the other end of the spectrum, that's pretty great for you. But for those who still get confused while defining frequency, here is an example. Take a look at this ball. It is jumping up and down in regular period. Consider this phenomenon, this ball going up and down, as an event, and we are observing it. Now, if we try to pan out a graph of time versus height of the ball, we would get something like this. Since the ball is continuously going up and down with time, the graph is not a straight line. It is not a curve either. It is a wave, and in this case, it's a periodic wave, which means that the waveform is repeating itself after every certain period. In this waveform, distance between any two identical extremes can be considered as a complete cycle. For example, if we consider two consecutive peaks of the graph, the ball was at the top of its jumping height at one point of time, then it went down, it jumped back again, and thus a cycle was completed. That's why the distance between them is called a cycle or one cycle. The length of the cycle is in terms of time, because here time is the x-axis. If we mark down seconds on the timeline, the exact cycle per second is called the frequency of the event. Here the frequency is 0.5 Hz, which means that in 1 second, half cycle of this event is getting completed. It is important to know that the frequency can be higher or lower than 1. If it's greater than 1, the event is completely finishing and also performing some of its next round within the duration of 1 second. Whereas if the frequency is below 1 Hz, it would mean that it takes more than a second to complete a full cycle of the event. In terms of radio communication, the frequency can range anywhere between kilohertz, megahertz, or even gigahertz, which means that transmitters or receivers can deal with millions or even billions of signals within a second. Let's take a look at some of the frequency bands used for multiple purposes. In next lecture, we will take a look at different frequency bands used for different purposes to get a broader picture of how frequency is utilized for communication purposes. Till then, happy learning, and I hope you have a nice day.